Colby, math.com.
Today in class we derived the formula for area of a triangle, which looks complicated but is actually not all that complicated once you see where the formula comes from. We're going to apply that formula to problem number 6 on this video. The NHL implemented a rule change to increase the size of hockey nets. See pictures below. Use the dimensions given to calculate the increase in trapezoidal area from the current net to the proposed net. So you see the current net is labeled blue. It follows this angle, and it has this base, this base. So we're going to use subscript notation to first find the area of the current net. Area of a trapezoid is equal to 1/2 multiplied by the sum of the bases, base 1 plus base 2, multiplied by the height of the trapezoid. I'm using the subscript notation C for current, for the current net. And then I'm going to substitute the values. You shouldn't do any computation until you substitute all your variable values and work vertically. If you need to do some kind of computation, you do it off on the side. The bases are the parallel sides of the trapezoid. That's what makes a trapezoid a trapezoid. It has exactly one pair of parallel, opposite parallel sides. And so and they're most often shown, as you see them here, as the top and the bottom, but it doesn't mean top and bottom, it means the sides that are parallel, so this side and this side. And so 1/2 of 18 plus 28 multiplied by the height. The height is the perpendicular distance between the bases. You know it's perpendicular because of this right angle symbol, and so the height of the trapezoid is 12 feet. Now, if you look at this, expression on the right side of our equation, we have 3 factors. We have 1/2 as one of our factors. This sum is the second of our factors, and the 12 is the third of our factors. And so, even though I know in PEMDAS you do parentheses first, if we're multiplying 3 factors, we have a series of multiplication we can associate to our advantage. So I can do 1/2 times 12. Before I even know what this sum is, or realizing that I'm going to have to multiply them all together in the end anyway. So 1/2 of 12 is 6, and so it'll be 6 multiplied by this sum, which is 46. 30 plus 16, yes. 6 40s is 240. 6 6s is 36. So 240 and 36 is 276. So the area of the current net is 276 square feet. During the pause, focus on the proposed net, the red outlined trapezoid, and find the area of the proposed net, and then try to find the increase in the trapezoidal area using those 2 areas, and come back after the pause and compare your work to mine.
Paused.
The proposed net has same height as the current net, and one of the bases is the same. This 28-foot base is still 28 feet, but this other base has been increased to 22 feet. Imagine to increase scoring and make the games more exciting would be my guess. So the area of the proposed net, we write the formula every time. 1/2 multiplied by B1 plus B2 multiplied by the height. The area of the proposed net will be 1/2 multiplied by 22 plus 28 multiplied by 12. I'm going to associate like we did with the current net. 1/2 of 12 is 6, and 22 and 28 is a sum of 50. So the area of the proposed net will be 6 multiplied by 50, or 300 feet squared. The increase in trapezoidal area will be the difference of those two. So 300 minus 276 is 24 square feet. Now you may have noticed a more clever and easier way to do this if you notice these triangles. Geometrically, or just looking at the picture, the increase in the trapezoidal area is equal to the total area of these two triangles. And since those triangles are congruent, you could sort of visualize in the same way that we did when we derived the area of triangle formula. You could visualize putting these two triangles together to make one parallelogram with a base of, well, let's do 22 minus 18 is 4, but that 4 is divided into two pieces here. So this base is 2. Base of either of these triangles is 2. And the height of these triangles, the perpendicular distance from the vertex to the base, this perpendicular distance, is the same as the height of the trapezoids. So 12. You do 2 times 12, you get 24, and that's the same. That's a much faster, much more efficient way of finding it if you notice that method was available to you. Thank you for watching tonight's video. I'll see you tomorrow.